In this example, we'll see how to apply heart rate data to design and evaluate some work task. So let's see, this is a problem. Assume that a package delivery driver, EPS or USPS, FedEx driver is a 40-year-old driver and then working for an 8-hour day shift, and then you collected the heart rate data as like this. So this is different situation. So while the person was driving, it's mostly driving for 4 hours, and then 100 beat per minute, taking package from the truck is 110 beat per minute, carrying the package, pushing kind of heavy package, and pushing, pulling maybe, lifting heavy load. So, and then lunch time. So all of these different activities and the amount of time the person use for that particular activity and the heart rate is provided here. And the resting heart rate you can simply measure by counting the number of pulses while the person is taking rest, which is 75 beat per minute. Typically it's the lowest heart rate from the monitor. Now typically this is not how you get from a heart rate monitor. From a heart rate monitor these days you get continuous data for 8 hours, and then you can simply get the average from there, so you really don't have to calculate that. However, if the situation is like this, oftentimes maybe there are standard data available for driving. Someone's heart rate gets around 100 beat per minute or so, then you can use this time weighted average to calculate the average heart rate for the entire shift. Now the question of interest is, what's the maximum heart rate for this driver? Now remember, this driver is just working, so you won't be able to, why my computer is not going backward. Okay, so you won't be able to actually collect the max heart rate. So the heart rate data you have seen before, it's just the activity data. So you're not pushing a person to go to their max. So in that case, you have to calculate by 220 minus age. So these are the question of interest. Let me go to, I am going to use MS Excel to kind of show all the calculation the question asked. So here are the activities heart rate. To calculate the time weighted heart rate, we can simply do for each of these different types of activities heart rate times the amount of time they spend on that heart rate, and then just copy that all the way down. Then I can sum all of these time weighted values and then divide by the total 8-hour shift. I can simply copy that right here, and then to get the average, simply this divide by the it's gonna be C8. I can't select that because it's too close, like that. So 106 is the time weighted value for that person. Let me bold this. Let's bold this, all of these cells, so I can just see the calculated value. Now resting heart rate is provided 75 beat per minute. Maximum heart rate, you have to use that 220 formula because definitely the person was not pushed, he was just working for that 8-hour period. So the max 160 heart rate is not his actual max. So this is the resting. 220 minus age is the max, not 220 minus resting. So that's the resting, that's the maximum heart rate for that person. And then to calculate reserve, check that video I have produced before how to calculate the reserve. So this minus this heart rate, so that's the person reserve. This is the person reserve or aerobic power, aerobic capacity. It cannot, for the purpose of this exercise or ergonomics, we can actually call this aerobic power or aerobic capacity. However, the most accurate term would be heart rate reserve. Now, there is a video on that. Check that too to kind of understand the difference between the aerobic power capacity and heart rate reserve. Now in this example, it can be considered they're kind of same. Now percent of aerobic power used or percent of heart rate reserve used during the driving. This is the driving heart rate minus the resting. So this is the driving heart rate minus the resting is 75. Then close the parenthesis, divide by the reserve times 100. We're calculating percentage. So 25% of the capacity the person is using while driving. Now for the entire task, I have to use the time weighted value for the entire task minus the resting divided by the reserve. Oops, did I do? It's probably multiply by 100. So 31%. And then what percent of time the person is in his max? So it's 160. It's asking for that, the percent of time the person spent on that very highest heart rate values. So that is this 160 minus 75 resting divided by the reserve times 100. So about 85%. The question also asked, what if the person is 25 years old compared to, it also asks, will the person be fatigued or not? What should you do if they get fatigued? Things like that. And also it asks you to compare with the 25 years old. Now, whether the person will get fatigued if the person goes over 30%, then the person will be fatigued. So if this condition met, then they will be fatigued. So the question is, yes, they will probably go fatigue if a person is 45 years old and work at this pace, will get fatigued. Now, what can you do to reduce the fatigue? You can reduce the rest break. You can reduce the handling heavy item heart rates, where the heart rate goes really very high. You can do that. So now to compare with the 25 years old, what I'm going to do is I will just copy this right here, Control C, just copy it as just values. This thing is just 31, like that. And then I'll change this to 25, so this number will be recalculated based on 25 years old, and this is for 45 years. So I'm going to write 45 here. So this is for the 45 years old. Now I'm going to change this to 25, and then this is calculated for 25. Now if you see that the 25 years old only spend 26% of his or her max capacity, while the 45 years old uses 31 of their max. So the 25 years old will be just perfectly fine with this job. You'll not be tired or fatigued. If you look at that 85 now, 85% of the max, which is anaerobic zone. So if a 45-year-old work at this rate, it's going to be anaerobic. The person will have some lactic concentration or fatigue, muscle fatigue, things like that. For the 25 years though, between 60 to 70% is the aerobic zone, so the person will be just fine in that range. So I hope this explains how to use heart rate monitor to evaluate or design some work tasks.